Welcome to this episode, which is going to be about categorical data, and in particular we're going to talk about categorical ordinal data, and that's data which is ordered by some implicit semantic value. It doesn't need to be numerical, and very often it isn't. So we'll look at importing these as usual, the two libraries we're going to use, matplotlib and pandas. So let's do that in Jupyter. I'll just switch now. So here's the first line. We can check, as always, the modules are there, and it finds them and loads them. And now we want to also check the data is there. Talk about the data in a second. So it's found the data and loaded it. So we can see the data here. It's read in from the ONS, so the original dataset's a national dataset, and it is about life satisfaction. It's a survey from 2012 to 2015 of the different regions of England. So there's 9 regions and they're listed here. And the scale we're using is low, medium, high and very high. So that's an ordinal scale. There's an order in there, but it's not ordered alphabetically. LMHV is not alphabetical, but it is ordered semantically for us. We can just check in the code that it's loaded that data set into a data frame for us. And indeed it has. There's a data frame. There are a number of things we need from the data frame. And I'll just show you the first one here. We need to get the categories from the dataset, and they're the column headers for the 4 columns and not the first column in the dataset. So first of all, we'll get all the columns. We do that using the .columns method, and that gives us a list. We want to get rid of the first of those and also turn it into a normal list just for neatness. So if I type ordinals now, you'll see it's extracted the column names from the dataset in the order in which they appear in the dataset. Now we need the values, and we're just going to extract those for the northeast for the moment. And there they are. You can double check those against the dataset and you'll find that they're the right ones. But also because I'm using this iLook, if you remember from the pandas episode early on that we introduced iLook as a feature for indexing into datasets, we're using iLook to get the first row, row 0, and the items from column 1, which is the second column in the dataset, column 0 is the first one, up to but not including 5. So that's the 4 column values associated with row 0. And that gives us the values for low, medium, high, and very high in the northeast of England. And we're just going to very quickly plot that in a very simple call to matplotlib. So there you see, hopefully, that there's a plot for the graph and that plot's showing us the values by proportion on the vertical scale. It tells us immediately that the northeast is largely high or very high in its satisfaction with life. It also tells us as a group who have a low satisfaction with their lives. As we'll see later, that's not unsurprising and is similar but not identical across the whole country. So that's one way to extract the 2 lists we need. So let's look at the southeast instead. So to extract the values for the southeast, we don't need to extract the column names again because we've already got those in the right order. We're going to use a different approach. We're going to extract using a filter. So we've got the dataset, satdf, and inside these brackets is a condition which, when true, it will extract rows from the dataset for us. So we're saying give us all of the rows in the dataset where area names is a string that contains southeast. This will, in this case, only be 1 row. You want to watch out that sometimes in real datasets it's more than 1 row. But here we know that it's only 1 row because there's only 1 row per region of England. That gives us a whole row, including the area name. We don't need that here, so we're going to drop it and we'll just keep the remaining values in the dataset. So we'll drop the area names column and keep the remaining 4 value columns. We'll then extract, because it's in the form of a series, we'll extract the values from that and then we'll turn it into a list. And note this little index here, we need value 0 to get that correct. That index is into what is an array. So if I type in vals se now, that combination of calls has produced the same row as above. Slightly more flexible, slightly more programmable because we're accessing by area region name rather than by guessing or knowing in advance an abstract index number. At this point we can plot this in exactly the same way as above. We've got the ordinals for the x-axis, we've got the values for the y-axis, and so we plot the southeast in purple. That's coming out slightly over 50 as very high, a little bit lower looking on low satisfaction. And we'll come back to a more detailed comparison in a minute. But you can see straight away we've got two separate plots of different data for different areas of the country with very similar patterns of life satisfaction. Now, one last thing I want to show you is using subplots in Python. So Matplotlib has this command called subplots, and here we're asking for one row of two subplots, and then we're going to plot one of our graphs in one of these rows and the other one in the other one. And because we've already extracted the values, we don't need to do that again. We're going to give this a subtitle, and you'll notice here fig refers to the whole figure with these subplots in it, whereas the axes 1 and 2 here are the two separate subplots. We're going to plot northeast and southwest data in. So axis 1, we make it a bar chart, we give it some ticks, we give it a limit. So we're going to make both bar charts the same height. This is quite important because if you want to compare bar heights across the row, you need the axes to be the same height for the bar heights to be comparable. And we'll create a grid, and I'll show you in a second what that does, and I'll also show you in a second this little thing here, Z order, and what that does. But let's plot this first. So there you go, that's these two plots above, side by side in a grid. Northeast is AX1, southeast is AX2, and now you can see that there's slightly higher numbers of people who are highly satisfied with their lives in the southeast. Similar numbers are very high. Lower numbers of people with a medium satisfaction rating, and lower numbers of people with a low satisfaction rating. So there's a slight shift in the southeast to being more satisfied with your life than in the northeast, but it's not a huge difference. You might imagine it was bigger, but maybe there's a trade-off here between cost of living and quality of life and other things which affect life satisfaction. A couple of things to notice here that I've done without explaining. So the first is to add these grid lines, and that's easily done. Once you've got these axes, you just do a y-axis.grid, and you can do similarly for the vertical axis if you want x-axis.grid, and it puts them in. Really useful for comparing. You'll see the bar height here and the bar height here, whether they're above and below 50. And then there's this Z order here. Matplotlib is drawing in 2D, but it has this idea of depth. And it will draw things with a higher Z order in front of things with a lower Z order. By default, the Z order is 1. So if I set the Z order to be 1, things will be drawn in the order they're given, or in the order that Matplotlib chooses. Here I haven't set any Z order for the northeast, and the grid lines go across the picture. But here, for the southeast, I've set the Z order to be 10 on the bars, not on the grids. So the bars are drawn in front of the grid, which will be a Z order of 1. So the higher the Z order, the further in front it becomes as a visual feature. That's very useful for sorting things into layers where you want some things to be more visible than other things. And here we want the data to stand out the most and the grid lines to be slightly less obvious. Okay, so that is categorical ordinal variables. The ordinal variable here is the x-axis, the satisfaction rating. There's a very clear order in the data semantically, even though it's neither alphabetic nor numeric. I'm going to show you one last example as a more complex example, which won't work very well here, and I'll explain why when I've run it. So supposing we wanted to show all of the regions in England, then we could do a loop across all the regions and through the data set, and I won't go into the details of this. It's essentially the same as above, and you will notice that the layout goes wrong, and at this point you need to start investigating how to lay out Matplotlib plots with a bit more space around them. So if you do that spacing and adjustments, and you can do this interactively if you're using Python in Visual Studio Code, you can eventually get these laid out more comfortably for viewing. And here you can see all 9 of the regions of England and all their data sets, and pretty much they're the same. There are small variations. If you look at very highly satisfied people, there are fewer of them in London than in the northeast. But then highly satisfied people, there are more of them in London and in the southeast. So thank you, and I'll see you again in another episode.